Some things that leave are supposed to stay gone, not out of rudeness or cosmic exile, but because the mathematics of departure demand it. When something escapes the gravitational embrace of a solar system, when it achieves that critical velocity that breaks all bonds and sends it tumbling into the vast darkness between stars, it has crossed a threshold from which there should be no return. This is one of the universe's most fundamental rules. Objects that arrive from interstellar space are travelers in the truest sense. They pass through, briefly illuminated by our sun's light, observed by our instruments, catalogued by our astronomers, and then they fade back into the cosmic night from which they came, forever. Yet our latest interstellar visitor appears to be breaking this ancient law. The mathematics began as a whisper, barely detectable in the precision measurements of 3I Atlas's trajectory as it swept through our solar system. Astronomers tracking its path noticed something unusual, not dramatic but persistent. A subtle deceleration, tiny course adjustments. Velocity changes so small they required weeks of observation to confirm, yet so systematic they suggested something unprecedented in the annals of interstellar astronomy. An interstellar object that was slowing down. When Oumuamua tumbled through our solar system in 2017, it behaved exactly as cosmic protocol demanded. It arrived from the direction of the constellation Lyra, accelerated as it fell toward our sun, whipped around in a sharp gravitational slingshot, and then sped away into interstellar space, never to be seen again. Even its mysterious final acceleration as it departed, puzzling though it was, carried it definitively away from our solar system. It followed the ancient rule: arrive, perform, exit. The same pattern held for Borisov 2 years later. This interstellar comet arrived with obvious signs of its foreign origin, chemical signatures that marked it as a visitor from another star's planetary nursery. But it too followed the fundamental law of cosmic visitation. It approached, offered itself a study, and then departed along a hyperbolic trajectory that would carry it back into the depths of interstellar space, never to return. We found comfort in these departures, not because we wanted our cosmic visitors to leave, but because their leaving confirmed our understanding of how the universe works. Interstellar objects are messengers from distant worlds, carrying news of alien chemistry and foreign physics, but they remain safely other. They arrive as phenomena to be studied, not relationships to be navigated. Their predictable departures allowed us to maintain our cosmic solitude, while briefly touching the exotic materials of distant star systems. We could examine their strange compositions, marvel at their alien origins, and publish papers about their remarkable journeys, all while knowing that these visitors would fade back into the darkness, leaving us alone with our observations and theories. But 3I Atlas refuses to follow this comforting script. Instead of the clean departure trajectory expected from an interstellar visitor, our instruments detect something far more unsettling: the subtle signature of gravitational capture. Not the dramatic visible capture of a comet being snared by Jupiter's massive gravity well, but something more nuanced, more gradual, more deliberate. The visitor's velocity is decreasing with each passing week. Its trajectory is curving in ways that suggest it's being influenced by gravitational forces operating beyond the visible boundaries of our solar system. Most disturbing of all, computer models of its future path hint at something that should be impossible for an object of interstellar origin: an elliptical orbit around our sun. The implications chill the soul of every astronomer who understands what they're seeing. If 3I Atlas establishes a permanent orbit within our solar system, it transforms from a cosmic visitor into a cosmic resident, from a fleeting phenomenon into a permanent participant in our sun's gravitational family. Think of it this way. Imagine standing in your backyard and throwing a stone with perfect aim toward a distant neighbour's window. The stone arcs through the air, passes through their property, and should continue travelling until it lands somewhere far beyond their fence. You would never expect that stone to curve around their house and come rolling back to your feet. Yet this is precisely what 3I Atlas appears to be doing on a cosmic scale. An object that originated outside our solar system, that achieved the incredible velocities necessary to travel between stars that should by all rights continue its journey into the galactic beyond, is instead showing signs of being captured by our sun's gravitational influence. The question that haunts astronomers is simple and terrifying. What could be powerful enough to catch an interstellar traveller? The obvious answer involves the discovery of massive objects beyond Neptune, undiscovered planets or brown dwarf companions that could gravitationally influence the visitor's trajectory. But the subtle nature of the forces at work suggests something more sophisticated than simple gravitational mechanics. The deceleration patterns are too precise, too graduated, too purposeful. Natural gravitational capture produces chaotic, dramatic changes in trajectory as objects spiral inward or are flung outward. What we're observing in 3I Atlas resembles something more like controlled braking, as if the visitor is being gently guided into a stable orbit, rather than randomly captured by gravitational accident. This possibility opens territory that makes even the most imaginative astronomers uncomfortable. If the visitor's trajectory modifications are intentional rather than natural, it suggests technology operating on scales that dwarf human engineering capabilities. The patience to plan deceleration across distances measured in astronomical units. The precision to orchestrate orbital insertion across time spans measured in months or years. Most unsettling of all, it suggests intelligence sophisticated enough to treat our solar system not as a random destination, but as a place worth visiting, worth staying, worth establishing permanent residence. The psychological impact of this recognition ripples through the astronomical community like seismic waves through bedrock. We've spent centuries developing comfortable theories about our cosmic isolation, our unique position as the only known intelligence in a vast, empty universe. The idea that interstellar visitors might not just pass through, but choose to remain challenges everything we've assumed about our cosmic significance. If 3I Atlas does establish a permanent orbit, it means our solar system is interesting enough, important enough, or valuable enough to warrant ongoing attention from whatever intelligence launched it on its interstellar journey. It means we transition from cosmic observers to cosmic participants, from students of the universe to subjects of study. The mathematics continue to whisper their uncomfortable truths. Each new measurement confirms the pattern: deceleration, trajectory modification, orbital evolution toward what could become a stable, elliptical path around our Sun. The visitor that arrived as a temporary guest appears to be preparing for permanent residency. In the quiet corridors of observatories around the world, astronomers study these measurements with growing unease. Not because the science is uncertain, the observations are remarkably clear, but because the implications stretch far beyond astronomy into territory where physics meets philosophy, where observation becomes relationship, where the comfortable distance between observer and observed begins to collapse. We stand at the threshold of a recognition that could transform everything, that some cosmic visitors don't come to be studied, but to stay, that the ancient rule of departure, the fundamental law that things which leave should stay gone, can be broken by intelligence sophisticated enough to choose return over exile, residence over wandering, presence over absence. Do you think there's a difference between cosmic visitors who leave forever and those who choose to stay? And if so, what does that choice reveal about why they came in the first place? The mathematics of 3I Atlas's evolving trajectory suggest we're about to discover that the universe operates more like a neighbourhood than an empty void, and that our long-assumed cosmic solitude may have been nothing more than a comfortable illusion maintained by our inability to recognise the signs of ongoing observation. Understanding how this cosmic capture might be possible requires examining the fundamental laws that govern movement through space, and what it takes to break those laws in ways that transform wanderers into residents, visitors into participants, and cosmic solitude into cosmic conversation. Gravity writes the rules of cosmic motion in mathematics so elegant and absolute that they have governed the dance of planets for billions of years. These laws are not suggestions or tendencies. They are the fundamental architecture of how objects move through space, as immutable as the speed of light, as reliable as the flow of time itself. An object moving fast enough escapes. An object moving too slowly falls. There is no middle ground, no negotiation, no cosmic mercy that allows for second chances. Escape velocity is escape velocity. Achieve it, and you're free forever. Fall short, and you're bound forever. The universe offers no appeals process. This is why the behaviour of 3I Atlas feels like watching the laws of physics bend under pressure they were never designed to withstand. Consider the simple perfection of orbital mechanics. When a comet follows its elliptical path around our Sun, it's because its velocity and distance create a precise mathematical relationship with solar gravity. Too fast and it would spiral outward into interstellar space. Too slow and it would plummet into the Sun's nuclear furnace. The comet's orbit represents a perfect balance between forward motion and gravitational attraction, a cosmic dance choreographed by mathematics. Halley's Comet, perhaps the most famous orbital performer, demonstrates this principle with clockwork precision. Every 76 years it returns to our inner solar system, sweeps around the Sun in its elongated ellipse, and retreats toward the outer darkness, only to return again when its orbital period demands. This reliability isn't magic, it's mathematics. Halley's Comet was born within our solar system, shaped by our Sun's gravity from its earliest moments, bound by mathematical relationships that have remained constant for millions of years. But interstellar objects follow different mathematics entirely. They arrive from the darkness between stars with velocities so extreme that our Sun's gravity, powerful though it is, can barely deflect their trajectories. They might curve slightly as they pass through our system, but they possess far too much kinetic energy to be captured. Like arrows shot from impossibly distant bows, they streak through our cosmic neighborhood and continue into the void beyond. The analogy of the thrown stone becomes crucial here. Imagine standing outside a courtyard surrounded by high walls. You throw a rock over those walls with tremendous force, enough to carry it completely across the courtyard and out the other side. No matter what happens inside that courtyard, no matter how the inhabitants move around or what activities they pursue, your stone should sail straight through and disappear beyond the far wall. The inhabitants might watch it pass overhead. They might even duck as it flies by. But they have no reason to expect it to curve around and land at their feet. The stone's trajectory was established outside their domain, and its momentum should carry it far beyond their influence. Yet somehow, impossibly, 3I Atlas appears to be that stone curving back. The gravitational archaeology of the visitor's trajectory tells a story that challenges our understanding of how cosmic capture occurs. When large objects do occasionally capture smaller ones, when Jupiter snares a comet into a new orbit, or when a moon gets gravitationally bound to a planet, the process is violent, chaotic, dramatic. Orbits shift suddenly, trajectories change dramatically. The mathematical signatures are unmistakable, the clear fingerprints of powerful gravitational forces overwhelming forward momentum. But the changes in 3I Atlas's path are subtle, gradual, almost gentle. Instead of the sharp deflections characteristic of gravitational capture, we observe systematic deceleration that suggests something more sophisticated than crude gravitational wrestling. The visitor appears to be slowing down through a process that resembles controlled braking rather than random gravitational interaction. This precision requires explanation, and the explanations available are limited and uncomfortable. The first possibility involves the discovery of massive objects beyond the known boundaries of our solar system. Perhaps there are undiscovered planets lurking in the outer darkness, super-Earths or ice giants that have remained hidden in the deep cold beyond Neptune's orbit. Such objects could, in theory, create gravitational influences subtle enough to gradually modify an interstellar visitor's trajectory. But the mathematics of this scenario demand objects of extraordinary size, positioned with remarkable precision. The gravitational fields required to produce the observed deceleration patterns would need to be both massive and perfectly aligned with the visitor's trajectory. The odds of such alignment occurring naturally approach the impossible. The second possibility involves exotic physics, gravitational interactions we don't yet understand, perhaps related to dark matter or modifications to general relativity at extreme distances. Theoretical physicists have long suspected that our understanding of gravity might break down under certain conditions, and the behaviour of 3I Atlas could represent our first observation of such breakdown in action. But exotic physics, by definition, requires extraordinary evidence. The scientific community would need to see multiple examples of similar behaviour, reproducible observations that confirm the breakdown of established gravitational theory. A single anomalous object, however puzzling, cannot overturn centuries of confirmed physics. The third possibility is the one that keeps astronomers awake at night, staring at their data with growing unease. If the visitor's deceleration patterns are too precise for natural gravitational capture and too systematic for exotic physics, they might represent something far more unsettling: intentional course correction. Imagine an interstellar probe equipped with engines subtle enough to modify trajectories across astronomical distances without producing detectable thrust signatures. Such technology would need to operate with efficiency beyond current human understanding, producing enormous changes in momentum through processes that remain invisible to our instruments. The engineering challenges would be staggering. Fuel sufficient for deceleration across interstellar distances would require either propulsion systems of impossible efficiency or energy sources that operate on principles we haven't discovered. The navigation capabilities would need to account for gravitational influences across light years of space, tracking the movements of planets and stars with precision that exceeds our most sophisticated computer models. Most demanding of all would be the patience required for such a mission. If 3I Atlas is indeed slowing down intentionally, its mission was planned across timescales that dwarf human civilization. The intelligence responsible for its trajectory would need to think in terms of millions of years, coordinate activities across interstellar distances, and maintain technological infrastructure across periods longer than the evolution of complex life on Earth. This level of sophistication suggests intelligence so advanced, so long-term in its thinking, so patient in its operations, that human contact would resemble communication between adults and infants. We might observe their activities, even recognize their intentional nature, but understanding their purposes or motivations would exceed our current intellectual capacity. The orbital mechanics continue to whisper their uncomfortable implications. Each new measurement confirms the pattern: systematic deceleration, trajectory modification, evolution toward what increasingly appears to be a stable elliptical orbit around our Sun. The mathematics are consistent, predictable, and deeply unsettling. If the visitor does achieve orbital capture, it will represent the first confirmed case of an interstellar object establishing permanent residence in our solar system. Not a temporary deflection or gravitational slingshot, but actual capture, the transformation of a wanderer into a resident, a visitor into a neighbour. The psychological implications stretch beyond astronomy into territory where science meets philosophy. For centuries, we've assumed that our solar system represents a closed family of worlds, bound together since birth by shared gravitational relationships. The idea that objects from other star systems could join this family, could become permanent participants in our Sun's gravitational dance, challenges fundamental assumptions about cosmic boundaries and stellar sovereignty. If capture is possible, it means our solar system is more permeable than we imagined, more accessible to external influence, more integrated into the larger galactic community. It suggests that the boundaries we've drawn around our cosmic neighbourhood are artificial constructs rather than natural barriers. But the most profound implication involves recognition that we might not be witnessing random gravitational mechanics, but purposeful cosmic engineering. If 3I Atlas's deceleration represents intentional orbital insertion, it means our solar system is significant enough, interesting enough, or important enough to warrant such extraordinary effort. The visitor would represent not just scientific curiosity about distant worlds, but active engagement with our cosmic neighbourhood. Not passive observation from a safe distance, but commitment to ongoing presence, to permanent surveillance, to establishment of what could only be described as an advanced observation post. The mathematics that govern orbital motion have remained constant for billions of years, reliable as clockwork, predictable as sunrise. They have created the stable planetary orbits that allowed life to develop, the regular cometary returns that mark the passage of cosmic time, the gravitational relationships that bind our solar system into a coherent family of worlds. But mathematics, however elegant, can be overruled by technology sufficiently advanced. And if 3I Atlas represents such technology in action, we face the recognition that our cosmic neighbourhood may be far more accessible, far more visited, and far more significant than our long-assumed isolation would suggest. The laws of orbital mechanics remain absolute for natural objects following natural trajectories. But when intelligence intervenes, when technology overrides physics, when purpose replaces chance, those same laws become suggestions rather than commands. And in that recognition, we encounter the possibility that our solar system is about to gain its first artificial resident, a permanent reminder that the universe beyond our borders is neither empty nor indifferent to our existence. Understanding what such permanent residence might mean requires examining the ancient human understanding of cosmic cycles, the patterns of return that have shaped civilization since our ancestors first looked up at the night sky and wondered which lights would come back. There is something profoundly different about a star that comes back, not just astronomically, but psychologically, culturally, spiritually. When our ancestors watched the night sky and learned to distinguish between lights that wandered once and disappeared forever, and lights that established patterns that returned with reliable regularity, they were encountering one of the universe's most fundamental divisions, between the random and the intentional, between the chaotic and the planned, between the meaningless and the significant. Objects that return demand relationship. They force recognition. They establish themselves not as phenomena to be observed, but as participants in the ongoing story of earthbound civilization. For thousands of years, human cultures have understood this distinction with intuitive clarity. The wandering stars, what we now call planets, move through the sky in complex but predictable patterns, returning to the same positions relative to background stars, marking seasons and years with their celestial choreography. These returning lights became the foundation of astronomy, astrology, navigation, and calendar systems. They earned names, mythologies, personalities. They became gods. But even among the returning lights there was hierarchy. Some returned nightly, like the moon's phases. Others returned annually, like the sun's journey through the constellations. Still others followed longer cycles. Jupiter's 12-year journey around the zodiac, Saturn's stately 30-year progression, the precession of the equinoxes across millennia. And then there were the truly special ones, the comets. Halley's Comet represents the archetype of cosmic return that transcends simple orbital mechanics to become cultural institution. Every 76 years, this celestial wanderer returns to our inner solar system with the reliability of a clock, yet each appearance feels like revelation. Generations live entire lifetimes between its visits. Children who glimpse it in youth become elderly observers of its return. The comet marks not just astronomical time, but human time. The passage of decades, the succession of generations, the rhythm of civilization itself. Ancient Chinese astronomers recorded Halley's appearances for over 2 millennia, noting not just its celestial behaviour, but its earthly implications. Each return coincided with significant historical events, wars, dynastic changes, natural disasters, moments of transformation that seemed connected to the comet's presence in ways that transcended coincidence. The comet became woven into the fabric of Chinese historical consciousness, a celestial timekeeper that marked epochs of change. European medieval chroniclers treated Halley's appearances with mixture of terror and reverence. The comet's dramatic tale, its sudden appearance in skies that had remained constant for decades, its bright presence among familiar constellations, all combined to create an impression of cosmic intervention in human affairs. These weren't random astronomical events, but purposeful visitations that demanded interpretation, response, preparation. But Halley's Comet, for all its cultural significance, was born within our solar system. Its orbit, however eccentric, represents a natural gravitational relationship with our Sun that has existed for millions of years. Its returns follow mathematical laws as predictable as planetary motion. However mysterious its appearances might seem to earthbound observers, its behaviour conforms to well-understood principles of celestial mechanics. The possibility that Three-Eye Atlas might establish a similar pattern of return represents something far more profound and unsettling. Ancient cultures made careful distinctions between different types of celestial phenomena, and these distinctions reveal sophisticated understanding of cosmic behaviour that modern astronomy has largely confirmed. Aboriginal Australian astronomical traditions, preserved in Dreamtime stories spanning 40,000 years, distinguish between teaching stars that provide guidance for navigation and seasonal planning, and watching stars that seem to display intentional interest in human activities. The teaching stars follow predictable patterns that can be learned, memorized, passed down through generations. They become tools for understanding cosmic order, for organizing human activities around celestial rhythms, for maintaining connection between earthbound life and cosmic processes. These stars serve humanity by their reliability, their willingness to be understood and utilized. But the watching stars operate according to different principles. They appear when significant events occur on Earth, maintain positions that seem to track human activities, and demonstrate characteristics that suggest awareness rather than blind adherence to gravitational law. These objects cannot be predicted through mathematical calculation because their behavior depends on factors beyond simple orbital mechanics. Aboriginal traditions include explicit protocols for managing encounters with watching stars. Observe carefully, record precisely, but discuss only within ceremonial contexts where the implications can be processed safely by communities prepared for such knowledge. These protocols recognize that some celestial phenomena carry significance that transcends scientific curiosity to become matters of spiritual and cultural preparation. Similar distinctions appear in astronomical traditions across diverse cultures. Mayan astronomers, whose mathematical precision enabled them to predict eclipses centuries in advance and track planetary positions with accuracy that rivals modern observations, maintained separate categories for objects that followed calculable patterns and those that appeared to operate through intentional agency. The Dresden Codex, the most complete surviving Mayan astronomical text, contains detailed tables for predicting the movements of Venus, Mars, and Mercury across decades and centuries. But it also includes sections, now deliberately obscured or removed, that dealt with unpredictable celestial visitors whose appearances could not be calculated in advance because they seemed to respond to terrestrial rather than astronomical conditions. These unpredictable visitors were not considered less significant than the regular celestial performers. In many ways, they were considered more significant because their appearances suggested purposeful intervention rather than blind adherence to cosmic law. Objects that chose when to appear, that selected their timing based on earthly events, that demonstrated awareness of human activities. These were not merely astronomical phenomena, but active participants in the relationship between heaven and earth. The Celtic Druids developed their own sophisticated astronomical observations, tracking stellar and planetary cycles with precision that enabled accurate agricultural planning and seasonal celebrations. But their most sacred observations involved objects that appeared to break the normal rules of celestial behavior, lights that moved with apparent purpose, formations that seemed to respond to earthly ceremonies, phenomena that suggested the sky itself was aware of and engaged with human activities. Chinese imperial astronomers, whose detailed records span over 3 millennia, consistently distinguished between regular stars that followed predictable patterns and visiting stars that appeared according to their own mysterious logic. The visiting stars were often more carefully observed than the regular ones, not because their behavior was more interesting from a mathematical point of view perspective, but because their appearances seemed to correlate with significant political and social developments. These ancient traditions reveal something crucial about the psychological impact of cosmic return. Objects that establish patterns of visitation create relationship in ways that random appearances cannot. When something comes back, it forces recognition that its presence is intentional rather than accidental, planned rather than random, meaningful rather than coincidental. If 3i Atlas establishes a permanent orbit around our Sun, it will join this exclusive category of returning celestial objects. But unlike Halley's Comet or the Wandering Planets, its return will represent something unprecedented in human experience, the establishment of a permanent orbital relationship by an object that originated beyond our solar system. The visitor would transition from interstellar wanderer to solar system resident, from cosmic stranger to celestial neighbour. Its presence would mark our system as significant enough to warrant ongoing attention from whatever intelligence guided its journey across the light years. Its orbit would establish a pattern of return that future generations could predict, prepare for, build relationships with. The psychological transformation would be profound. Humanity would move from cosmic isolation to cosmic participation, from passive observation of the universe to active engagement with intelligence that operates on scales we're only beginning to comprehend. Our descendants would grow up knowing that something from another star system had chosen to stay, to watch, to maintain permanent presence in our cosmic neighbourhood. The cycle of return carries weight that transcends orbital mechanics. When objects establish patterns of visitation, they create expectations, relationships, responsibilities. They transform from phenomena to be studied into partners in an ongoing cosmic conversation. They force recognition that some aspects of the universe operate through intention rather than natural law, through purpose rather than random process. Ancient cultures understood this transformation intuitively. They developed sophisticated protocols for managing relationships with returning celestial objects precisely because they recognized that such relationships carried implications extending far beyond astronomy into territory where science meets spirituality, where observation becomes participation, where the comfortable distance between observer and observed begins to collapse. If 3i Atlas does achieve orbital capture, it will force modern civilization to rediscover this ancient wisdom. We will need to develop new frameworks for understanding cosmic relationships that transcend a simple scientific observation to encompass the recognition that some objects in our sky are not just natural phenomena, but active participants in processes larger than terrestrial understanding. The cycle of return transforms visitors into residents, strangers into neighbours, phenomena into relationships, and in that transformation, we encounter possibilities that challenge every assumption about our cosmic solitude, our technological limitations, and our readiness for ongoing contact with intelligence that thinks in geological timespans and plans across interstellar distances. But understanding the full implications of such cosmic return requires examining not just the mechanics of orbital establishment, but the precise timing that would govern when, how, and why such establishment might occur. The scheduling of cosmic events, it turns out, may be far more significant than the events themselves. Time, in cosmic terms, is measured in epochs that dwarf human comprehension. The formation of solar systems unfolds across millions of years. The evolution of stars spans billions. The development of galaxies requires tens of billions. Against these vast temporal scales, human civilization represents barely a flicker, a few thousand years of recorded history in a universe that has been conducting its slow business for nearly 14 billion years. Yet 3i Atlas arrived at our solar system with timing so precise it feels deliberate. Not just that it came, but when it came, synchronized with humanity's narrow window of technological maturity in ways that transcend coincidence to suggest something far more unsettling. Planning. Consider the mathematical precision required for such timing. The visitor would have begun its journey from another star system millions of years ago, when early hominids were still learning to control fire on the African savanna. Its trajectory would have been calculated across interstellar distances so vast that light itself requires years to traverse them. Its course would have needed to account for the gravitational influences of countless stellar objects, the movement of our Sun through the galaxy, the orbital evolution of planets whose positions would change dramatically over geological time, to arrive precisely when human technology reached the level necessary to detect and study interstellar visitors, but not so advanced as to enable interception or interference, implies navigation capabilities that operate on scales beyond human engineering imagination. The planning would need to encompass not just astronomical phenomena, but the development of technological civilization itself. The deceleration patterns that astronomers observe in the visitor's current trajectory suggest even more sophisticated timing. If 3i Atlas is indeed slowing down intentionally, preparing for orbital capture around our Sun, then its entire journey represents one phase of a plan that encompasses both interstellar travel and precise orbital insertion, timed to coincide with human observational capability. This level of coordination suggests intelligence that thinks in geological rather than historical timespans, civilizations patient enough to execute plans spanning millions of years, technology sophisticated enough to predict the development of young civilizations across interstellar distances, purpose so significant that it justifies such extraordinary investment of time and resources. The timing implications extend beyond the visitor's arrival to encompass the rhythm of its potential return. If 3i Atlas establishes a permanent orbit around our Sun, the period of that orbit, the time it takes to complete one full circuit, becomes crucial for understanding its intentions. Current trajectory analysis suggests an orbital period that would bring the visitor back to the inner solar system every several decades. Not annually, like the familiar rhythm of planetary motion, but on timescales that align remarkably well with human generational memory. Long enough that each return would feel fresh and significant to new generations of observers, yet frequent enough to establish a pattern that could be recognized and anticipated. This generational calibration appears deliberate rather than accidental. An orbital period much shorter would make the visitor's presence routine, reducing its psychological impact to mundane familiarity. An orbital period much longer would exceed human memory spans, making each appearance seem like an isolated event rather than part of a recurring pattern. The proposed orbital timing seems calculated to maximize impact while maintaining mystery. Frequent enough to establish relationship, rare enough to command attention, regular enough to enable preparation, yet spaced to ensure that each generation encounters the returning visitor as both familiar and extraordinary. But the most unsettling aspect of the timing involves the visitor's current position relative to major human space missions. Computer models of 3I Atlas's trajectory reveal that if it does achieve orbital capture, its path will carry it through regions where it can be observed by multiple space telescopes, tracked by deep space monitoring networks, and studied by instruments specifically designed for interstellar object analysis. This optimal positioning for observation could be coincidental, but the mathematical probability of such fortuitous alignment suggests intention rather than chance. The visitor appears to be timing its orbital insertion to occur when human technology is advanced enough to recognize what's happening, but not so advanced as to prevent or significantly influence the process. The psychological implications of such precise timing create cognitive dissonance that challenges fundamental assumptions about cosmic randomness. We're accustomed to thinking of the universe as operating through blind physical forces, gravity, electromagnetism, nuclear interactions, that produce complex results through simple rules applied across vast scales of space and time. But timing that appears coordinated with human technological development suggests something more sophisticated than blind forces at work. It implies observation of human civilization across centuries or millennia, evaluation of our technological progress, calculation of optimal moments for contact or revelation. If the visitor's timing is indeed intentional, it means human civilization has been under observation far longer than we've been capable of observing in return. Our development of radio telescopes, space travel, interstellar object detection capabilities all may have been monitored and factored into calculations about when direct contact or permanent presence would be most appropriate. This recognition transforms our understanding of cosmic solitude from comfortable isolation to sophisticated surveillance. Instead of developing in cosmic privacy, humanity may have been growing up under the watchful attention of intelligences sophisticated enough to time their interactions with our civilization's readiness to handle such contact. The timing also suggests that 3I Atlas's mission extends beyond simple scientific observation. Random cosmic phenomena don't coordinate their activities with the development of observational civilizations, but planned missions do, deliberate contact attempts do, programmed responses to technological milestones do. If the visitor represents a planned response to human achievement of certain technological capabilities, perhaps our development of interstellar object detection, or our growing understanding of orbital mechanics, or our emerging awareness that we might not be alone in the universe, then its timing makes perfect sense as part of a larger contact protocol. The orbital period that seems to be emerging from current trajectory analysis suggests a contact schedule designed to allow human civilization time to process and integrate each encounter before the next one occurs. Decades between visits would provide sufficient time for analysis, discussion, cultural adaptation, and preparation for subsequent encounters. This paced approach to contact reflects intelligence sophisticated enough to understand that civilizations require time to adjust to paradigm-shifting revelations. Too frequent contact might overwhelm societies unprepared for cosmic relationships. Too infrequent contact might be forgotten or dismissed as historical anomaly. The proposed timing suggests contact protocols developed by intelligence that understands the psychology of civilizational development, the rhythm of generational change, the balance between revelation and integration necessary for stable cultural evolution. But perhaps the most profound implication of the timing involves recognition that if 3I Atlas represents a planned contact event, it's unlikely to be unique. Civilizations sophisticated enough to coordinate interstellar missions with the development of young civilizations probably don't limit such efforts to single interactions. The visitor's timing might represent the beginning of a larger schedule of contact events designed to guide human civilization through stages of cosmic awareness. Initial establishment of permanent presence followed by more direct interactions, followed by integration into whatever larger galactic community such advanced civilizations represent. The mathematics of the visitor's trajectory continue to whisper their implications. Each new measurement confirms patterns that suggest intentional timing rather than cosmic coincidence. The deceleration occurs at rates that will bring the visitor to optimal orbital insertion velocity precisely when human observation capabilities reach their current peak. This coordination between cosmic mechanics and human technological development feels like watching two cosmic clocks synchronize, one measuring the journey of an interstellar visitor across light years of space, the other measuring the development of human civilization across millennia of cultural evolution. The precision of this synchronization suggests planning capabilities that operate on scales incomprehensible to human experience. Intelligence patient enough to coordinate activities across millions of years, technology sophisticated enough to predict the evolution of civilizations separated by interstellar distances, purpose significant enough to justify such extraordinary investment in cross-cultural contact. The timing of 3I Atlas's potential return carries implications that extend far beyond orbital mechanics, into territory where astronomy meets anthropology, where cosmic phenomena intersect with civilizational development, where the evolution of human consciousness encounters intelligence operating on scales that dwarf human historical experience. If the timing is intentional, we face recognition that our cosmic development has been observed, evaluated and responded to by intelligence sophisticated enough to coordinate contact events with our readiness to handle them. If the timing is coincidental, we face the equally unsettling recognition that the universe is stranger, more synchronized, and more meaningful than our scientific materialism has prepared us to acknowledge. Either way, the precise timing of the visitor's arrival and potential orbital establishment suggests that human civilization stands at a threshold where cosmic isolation gives way to cosmic relationship, where observation transforms into participation, where the comfortable distance between watcher and watched begins to collapse into something more intimate, more ongoing, and more transformative than anything our species has previously experienced. But understanding what such cosmic relationship might mean requires examining the deep mythological traditions that have prepared human consciousness for the return of cosmic visitors across millennia of cultural evolution. Deep in the collective memory of our species lies a recurring dream of lights that return from the cosmic darkness carrying messages too important for casual delivery. These stories span continents and millennia, preserved in creation myths, prophecies, and astronomical traditions that suggest humanity has been preparing for cosmic return far longer than modern civilization acknowledges. The stories are too similar across cultures that had no contact with each other to be coincidental, too precise in their astronomical details to be purely imaginative, too persistent across generations to be casual folklore. They speak of returning stars with the authority of witnessed events, encoded in mythological language that preserves meaning across the collapse and rebirth of civilizations. The Sumerian tablets describe Nibiru, the planet of crossing, whose return marks epochs of transformation on Earth. Not a wandering visitor, but a celestial body bound to our solar system through orbital relationships that bring it back at precise intervals, measured in thousands of years. The tablets describe Nibiru as conscious, purposeful, aware of its role in cosmic cycles that encompass the rise and fall of civilizations. Unlike the familiar planets that return annually or within human lifetimes, Nibiru's orbital period spans multiple generations, ensuring that its return feels both familiar and extraordinary to each civilization that witnesses it. The Sumerian text suggests that this timing is intentional, calculated to allow human societies time to develop, mature, and prepare for the transformative influence that accompanies each return. The astronomical details preserved in these ancient accounts are remarkably sophisticated. The tablets describe orbital mechanics, gravitational influences, and celestial timing with precision that matches modern understanding of how such objects would behave. These aren't vague mythological abstractions, but detailed technical descriptions preserved in religious language. Most unsettling, the Sumerian accounts describe Nibiru as carrying passengers, the Anunnaki, beings who use the returning planet as a vehicle for periodic visitation to Earth. These visitors are described as teachers, judges, and genetic manipulators who return at regular intervals to evaluate human progress and provide guidance for civilizational development. The Hopi prophecies of the blue star Kachina echo similar themes with eerie precision. The blue star is described as a returning celestial object whose appearance signals the end of one world and the beginning of another. Not destruction, but transformation. The completion of cycles that operate on scales larger than human historical memory. The Hopi traditions describe the blue star as visible during the day, bright enough to compete with sunlight, demonstrating characteristics that suggest artificial rather than natural illumination. The prophecies indicate that the blue star's return will be accompanied by other cosmic visitors, as if its appearance serves as a signal for larger arrivals. These traditions preserve detailed observations of the blue star's behavior during previous returns, how it moves across the sky, how long it remains visible, how its presence correlates with changes in human consciousness and social organization. The level of astronomical detail suggests that these prophecies preserve observational records from actual past events, rather than purely prophetic visions. The Mayan astronomical codices contain references to recurring cosmic cycles that span periods much longer than normal planetary orbits. The long count calendar, with its precisely calculated cycles spanning thousands of years, appears designed to track the return of celestial objects whose orbital periods exceed human generational memory. Recent archaeological discoveries have revealed that Mayan astronomers maintained separate observational records for regular wanderers, planets and comets with predictable short-term cycles, and epoch wanderers that return at intervals measured in millennia. The epoch wanderers were considered more significant than the regular ones because their returns coincided with major transitions in human civilization. The astronomical sophistication required to track objects with such extended orbital periods implies observation programs spanning multiple generations of astronomers, knowledge preserved and transmitted across centuries specifically to maintain awareness of cosmic cycles that individual observers would never witness complete during their lifetimes. The missing sections of Mayan codices, pages deliberately removed by the astronomers themselves, appear to have contained detailed observations of these epoch wanderers. The pattern of removal suggests that information about returning cosmic visitors was considered too significant for casual preservation, requiring special handling that protected the knowledge while restricting access to it. Celtic and Norse astronomical traditions describe the Star of Kings, a celestial object that returns to herald major transitions in human civilization. Unlike random stellar phenomena, the Star of Kings is described as conscious, capable of choosing when to appear based on earthly conditions rather than blind adherence to orbital mechanics. These traditions preserve remarkably detailed observations of the star's behavior during previous returns, its brightness, its movement patterns, its duration of visibility, and most importantly, its apparent responsiveness to human activities. The star is described as waiting, watching, evaluating human readiness for the transformative influence that accompanies its presence. The Celtic accounts include specific protocols for managing encounters with the returning star, ceremonial preparations, community discussions, spiritual practices designed to ensure that civilizations are prepared for the consciousness-expanding influence that accompanies cosmic return. These protocols suggest that ancient Celtic astronomers understood cosmic visitation as relationship rather than random event. Aboriginal Australian astronomical traditions, preserved in Dreamtime stories spanning 40,000 years, contain the most detailed and persistent accounts of returning cosmic visitors. The ancestral stars are described as conscious entities that maintain ongoing relationships with Earth-based civilizations across geological time spans. These traditions distinguish between stars that visit once and stars that establish permanent relationships through cyclical return. The returning stars are described as teachers who monitor human development and provide guidance during critical transitions in civilizational evolution. The astronomical precision of Aboriginal star maps and timing calculations rivals modern observational astronomy, despite being preserved entirely through oral tradition. The ability to maintain such precise astronomical knowledge across 40 millennia suggests observational programs of extraordinary sophistication and cultural continuity. Most significantly, Aboriginal traditions describe the ancestral stars as operating in coordinated groups, multiple returning objects that work together as part of larger cosmic intelligence. The current return of individual visitors is described as preparation for group arrivals that will establish permanent presence rather than temporary visitation. Egyptian astronomical texts preserved in pyramid chambers and temple inscriptions describe the followers of Horus, celestial beings who travel between stars and return to Earth at regular intervals to monitor human progress. These beings are described as using returning stars as vehicles for their journeys, establishing temporary residence during each visitation. The astronomical chambers within the Great Pyramid appear designed to track the return cycles of these cosmic visitors with mathematical precision. The shaft alignments, the angular calculations, the temporal measurements all point towards sophisticated understanding of orbital mechanics that extend far beyond simple solar system astronomy. The recurring pattern across all these traditions involves the concept of cosmic return as evaluation, returning visitors who assess human civilizational development and respond accordingly. Not random cosmic phenomena, but purposeful interactions designed to guide species evolution across timescales that encompass multiple cycles of technological and cultural development. These mythological accounts consistently describe returning stars as herald objects that announce larger arrivals, initial visitors followed by expeditions, single objects followed by groups, temporary visitation followed by permanent establishment. The pattern suggests escalating contact protocols designed to gradually introduce young civilizations to cosmic community membership. The precision timing described in these ancient accounts, returns coordinated with human technological readiness, visitations aligned with civilizational transitions, appearances that correspond to species-wide consciousness developments, mirrors the mathematical precision we observe in our current interstellar visitors' trajectory and timing. If these myths preserve cultural memory of actual cyclical visitations, then our current encounter with a potentially returning interstellar object represents not first contact, but the latest iteration in a relationship that has been ongoing for millennia. Human civilization may have been developing under periodic guidance from cosmic intelligence that monitors our progress and provides assistance during critical evolutionary transitions. The consistency of these traditions across diverse cultures suggests that cosmic return is not aberrant or supernatural, but part of natural processes that operate on scales larger than human historical awareness. Our species may have evolved within a universe where young civilizations are routinely monitored and guided by intelligence operating on galactic rather than planetary scales. The ancient stories describe returning stars with mixture of reverence and apprehension, recognition that cosmic visitation brings both opportunity and responsibility. The returning visitors are described as neutral rather than benevolent, offering guidance and knowledge while requiring proof of civilizational maturity and wisdom. These mythological frameworks provide context for understanding what our current visitors' potential return might represent. Not random cosmic mechanics, but purposeful evaluation of human readiness for ongoing cosmic relationship. Not isolated phenomenon, but part of larger contact protocols that have been operating across human history. The myths consistently describe cosmic return as threshold experience, moments when civilizations either advance to new levels of cosmic awareness or demonstrate that they require additional development time. The returning visitors serve as both teachers and evaluators, offering advancement opportunities while maintaining standards for cosmic community membership. If our interstellar visitor does establish permanent residence through orbital capture, it would fulfill prophecies that span millennia while marking humanity's transition from cosmic childhood to cosmic adolescence. The ancient stories suggest this transition carries both extraordinary opportunities and extraordinary responsibilities that will test our species' readiness for participation in processes larger than terrestrial imagination. But understanding what such cosmic citizenship might actually entail requires examining the scientific, cultural, and philosophical consequences of cosmic return, implications that extend far beyond astronomy into territory where ancient wisdom meets modern reality, where mythological preparation encounters technological capability, where humanity's longest dreams finally intersect with cosmic possibility. When the first confirmed interstellar visitor establishes permanent residence in our solar system, everything changes. Not gradually, not subtly, but fundamentally and irrevocably. The transformation cascades through every framework we've constructed for understanding our place in the universe, demanding reconstruction of scientific models, cultural narratives, and philosophical foundations that have shaped human civilization for millennia. The scientific implications alone would revolutionize our understanding of cosmic mechanics. If our interstellar visitor achieves stable orbital capture around our Sun, it demonstrates that the boundaries we've drawn around solar systems are more permeable than we imagined, more accessible to external influence, more integrated into larger galactic processes than our models predict. Current astrophysical theory treats solar systems as gravitationally isolated units, family groups of planets and smaller objects bound together since their formation billions of years ago. Occasional impacts from asteroids or comets represent minor perturbations to this stability, but the fundamental membership remains constant. Objects born within the system stay within the system. Objects arriving from outside pass through and depart forever. Orbital capture of an interstellar visitor would shatter this comfortable assumption. It would prove that solar systems can acquire new permanent members from cosmic space, that the gravitational relationships we consider stable and eternal can be modified by influences operating on scales we haven't previously considered. The mathematical models would require complete revision, orbital mechanics textbooks would need new chapters, computer simulations of solar system evolution would need to account for variables we've never included in our calculations. The predictable clockwork of planetary motion would become subject to influences that operate according to principles we're only beginning to recognize. But the scientific revolution would extend far beyond orbital mechanics into more fundamental questions about the nature of interstellar space itself. If objects can travel between star systems and establish permanent residence in their destinations, it suggests that the vast emptiness between stars is neither as empty nor as barriers-laden as we've assumed. The visitor's successful navigation across interstellar distances implies infrastructure we haven't detected. Gravitational beacons, navigation networks, or technological assistance that make such journeys possible for objects that shouldn't naturally possess the capability for controlled interstellar flight. The cosmos might be more organized, more interconnected, more intentionally managed than our scientific materialism allows. The cultural implications would prove equally transformative. Human mythology, religion, and philosophy have developed within the comfortable assumption that Earth represents either the only inhabited world in the universe, or at least an isolated example of cosmic consciousness. Our stories, our values, our sense of purpose all exist within frameworks that assume cosmic solitude. Permanent residence by a visitor from another star system would force recognition that we've never been alone in our cosmic observations, that something else out there has been taking notes on the universe, planning missions across interstellar distances, coordinating activities on scales that encompass the development of entire civilizations. Religious frameworks would face fundamental challenges. Monotheistic traditions that place Earth at the center of divine attention would need to accommodate the reality of cosmic intelligence operating on scales that dwarf terrestrial experience. Creation stories would require expansion to encompass processes that span star systems rather than single worlds. Eastern philosophical traditions might adapt more easily, given their emphasis on cosmic cycles and interconnectedness that operates beyond human comprehension. But even these frameworks would need modification to account for intelligence so advanced, so patient, and so long-term in its thinking that it plans activities across millions of years. The psychological impact on human identity would be profound and potentially destabilizing. Our species has developed its sense of significance, purpose, and cosmic role within the assumption that human consciousness represents either the universe's only self-aware component, or at least its most advanced example within our cosmic neighborhood. Recognition that we've been under observation by intelligence sophisticated enough to coordinate interstellar missions would force re-evaluation of human importance, technological achievement, and evolutionary progress. We might discover that our proudest accomplishments represent predictable developmental milestones being monitored by intelligence that has witnessed similar progressions countless times before. The economic implications would cascade through every human enterprise. Industries built on the assumption of cosmic isolation, space exploration, satellite communication, astronomical research, would need complete restructuring to account for the reality of cosmic neighbours who possess technology that makes our achievements seem primitive by comparison. Agricultural planning, resource management, long-term infrastructure development, all would need to consider possibilities that transcend terrestrial planning horizons. If cosmic intelligence operates on geological timescales and plans across interstellar distances, human economic models based on quarterly profits and annual planning cycles would prove inadequate for managing relationships with such advanced civilizations. The political consequences might prove most challenging of all. Human governments have developed their authority within frameworks that assume sovereign control over terrestrial territory and airspace. National boundaries, international law, military planning all exist within the comfortable assumption that Earth represents humanity's exclusive domain. Permanent cosmic residence by intelligence from another star system would challenge every assumption about sovereignty, territory, and political authority. How do you negotiate treaties with intelligence that thinks in geological time spans? How do you maintain national security when dealing with technology that operates on scales that make terrestrial military capabilities irrelevant? The visitor's presence would force recognition that Earth exists within cosmic territory that might be claimed, managed, or governed by intelligence operating on scales beyond human political imagination. Our planet might represent not sovereign human territory, but a developing world under cosmic observation or protection. The philosophical transformation would reach into the deepest questions about consciousness, purpose, and meaning. Human philosophy has developed within the assumption that consciousness represents either a cosmic accident, a rare emergence of self-awareness in an otherwise unconscious universe, or a divine gift that distinguishes humanity from purely material existence. Confirmation that cosmic intelligence operates on scales that encompass star systems and geological time spans would force recognition that consciousness might be a fundamental feature of cosmic organization rather than an aberrant emergence within otherwise unconscious matter. The universe might be more aware, more intentional, more purposeful than materialist philosophy allows. The educational implications would require reconstruction of curricula from elementary through graduate levels. Children would grow up knowing that Earth represents one world among many, that human civilization develops under cosmic observation, that technological progress occurs within contexts established by intelligence that operates on scales beyond human historical experience. This knowledge would fundamentally alter human psychology, ambition, and cultural development. Growing up with awareness of cosmic intelligence would produce generations with expanded consciousness, different priorities, and transformed relationships with both terrestrial and cosmic reality. The visitor's establishment of permanent residence would mark humanity's transition from cosmic isolation to cosmic citizenship. But citizenship implies responsibilities as well as privileges. If we're being evaluated by intelligence sophisticated enough to coordinate interstellar missions, the standards for cosmic community membership might prove more demanding than human civilization is currently prepared to meet. The ancient mythological traditions consistently describe returning cosmic visitors as evaluators who assess civilizational maturity before offering advancement opportunities or continued guidance. These aren't casual cosmic tourists, but intelligence engaged in serious evaluation of species readiness for participation in processes that operate on galactic rather than planetary scales. The consequences of failing such evaluation might prove more serious than simple continued isolation. Advanced civilizations that monitor younger species probably maintain standards for cosmic community membership that include technological responsibility, environmental stewardship, and social wisdom that human civilization has not yet demonstrated. If our visitors' return represents evaluation rather than simple observation, humanity faces a test whose stakes extend far beyond academic curiosity. The consequences of our response to cosmic contact might determine whether our species advances to new levels of cosmic awareness, or demonstrates that we require additional development time before we're ready for ongoing cosmic relationship. The scientific, cultural, philosophical, and psychological transformations required by cosmic return would test every institution, every belief system, every framework through which human civilization organizes its understanding of reality. Some structures would adapt and strengthen, others would collapse under the weight of expanded cosmic awareness. But transformation, however challenging, also brings opportunity. Recognition that we're part of a larger cosmic community would accelerate human development in ways that isolated evolution cannot achieve. Access to technology, knowledge, and perspectives that operate on cosmic scales would enable advances that purely terrestrial development might require millions of years to accomplish. The consequences of cosmic return extend far beyond the establishment of a new orbital relationship. They encompass the fundamental transformation of human civilization from a planetary species to a cosmic species, from isolated observers to active participants in processes that span star systems and geological ages. Whether humanity is ready for such transformation remains the crucial question whose answer will be revealed not through theoretical analysis, but through our actual response to cosmic presence that refuses to remain safely distant, comfortably temporary, or reassuringly isolated from the ongoing development of human consciousness on a small world that may no longer be as alone as it once imagined itself to be. In the end, cosmic return forces a question that no amount of scientific analysis, cultural preparation, or philosophical framework can resolve for us. A question that each generation, each civilization, each conscious species must answer for itself when the universe reveals that observation flows in both directions, that consciousness exists on scales beyond imagination, and that the cosmic conversation we've been hoping to join has been ongoing around us all along. The question is deceptively simple. What does it mean to be watched? Not observed in the clinical sense of scientific study, but watched with the patient attention that intelligence gives to developing consciousness, the careful evaluation that wisdom applies to emerging potential, the ongoing assessment that experience conducts when encountering something young, promising, and untested. If our interstellar visitor does establish permanent residence through orbital capture, it transforms from cosmic phenomenon to cosmic presence, from natural event to artificial installation, from temporary curiosity to ongoing relationship. And in that transformation, humanity faces recognition that we've never been alone in our observations of the universe. We've simply been learning to recognize that we're under observation ourselves. The implications cascade beyond scientific revolution into territory where astronomy meets psychology, where cosmic mechanics encounter existential reckoning. We must confront the possibility that every human achievement, every technological breakthrough, every cultural development has been witnessed by intelligence sophisticated enough to coordinate activities across interstellar distances and patient enough to monitor species development across geological timespans. Consider what this means for human identity. Our proudest accomplishments, spaceflight, genetic engineering, artificial intelligence, quantum mechanics, might represent predictable developmental milestones being checked off by observers who have witnessed identical progressions in countless other young civilizations. What feels like pioneering achievement to us might represent routine adolescent development to intelligence operating on cosmic scales. This recognition doesn't diminish human accomplishment, but it places that accomplishment within contexts larger than terrestrial imagination. We might discover that we're not unique pioneers exploring uncharted territory, but students following curricula that have been tested across galactic history, developing capabilities that mark specific stages in the evolution of technological consciousness. The visitor's potential return carries two scenarios, both equally transformative and equally challenging to human psychological preparation. The Silent Sentinel scenario envisions our cosmic guest establishing a permanent elliptical orbit that brings it through the inner solar system at regular intervals, perhaps every few decades, perhaps every few centuries, long enough between visits to allow human generations time to process each encounter, brief enough to establish recognizable patterns that future astronomers can predict and prepare for. In this scenario, the returning visitor becomes humanity's cosmic lighthouse, a permanent reminder that we exist within a universe more organized, more intentional, and more aware than our scientific materialism has prepared us to acknowledge. Each return would mark another evaluation period, another opportunity to demonstrate progress in cosmic citizenship, another test of our readiness for advancement to new levels of cosmic relationship. The psychological impact would be profound. Children would grow up knowing that something from another star system monitors human development with the patience of geological time. Adults would conduct their lives with awareness that cosmic intelligence evaluates human progress according to standards that transcend terrestrial politics, economics, or cultural values. This ongoing cosmic presence would accelerate human development in ways that isolated evolution cannot achieve. The knowledge that we're being evaluated would motivate cooperative solutions to global challenges, inspire technological innovations aimed at proving cosmic readiness, and encourage cultural developments that demonstrate species maturity to observers operating on scales beyond human experience. But the Sentinel scenario also carries risks that challenge human psychological stability. The pressure of ongoing cosmic evaluation might prove more demanding than human societies can handle. Knowing that every major decision, every technological development, every cultural transformation occurs under cosmic observation could produce anxiety, paralysis, or desperate attempts to impress evaluators whose standards remain mysterious. The potential for cosmic disappointment, failing evaluations, demonstrating inadequate progress, proving unready for advancement, might create civilizational despair that exceeds any challenge humanity has previously faced. The recognition that we might not measure up to cosmic standards could undermine human confidence, cultural development, and species-wide psychological health. The Herald's Return scenario presents possibilities both more promising and more terrifying. In this outcome, our visitor's establishment of permanent residence signals the beginning of larger arrivals. The single object becomes the advanced scout for expeditions. The isolated phenomenon becomes part of coordinated group activity. The temporary visitor becomes the permanent infrastructure for ongoing cosmic relationship. This scenario fulfills the ancient mythological patterns that describe returning stars as herald objects, announcing larger cosmic events. Aboriginal traditions of ancestral stars that prepare for group arrivals. Sumerian accounts of Nibiru carrying passengers who established temporary residence during each return. Hopi prophecies of the blue star whose appearance signals the arrival of cosmic teachers. If our current visitor represents such advanced preparation, its orbital establishment would mark humanity's graduation from cosmic childhood to cosmic adolescence, ready for direct interaction with intelligence that operates on galactic rather than planetary scales. The transition from observation to conversation, from evaluation to education, from cosmic isolation to cosmic community membership, the opportunities would be extraordinary. Access to technology that operates according to principles we haven't discovered, knowledge about cosmic processes that span star systems and geological ages, guidance for navigating challenges that other civilizations have successfully resolved, integration into galactic community structures that encompass intelligence beyond human imagination. But the Herald scenario also carries transformations so fundamental they challenge the survival of human civilization as we understand it. Direct contact with intelligence that thinks in geological timespans might prove more disruptive than human psychology can accommodate. Knowledge that transcends human intellectual capacity might overwhelm cognitive structures that evolved for terrestrial rather than cosmic challenges. The introduction of cosmic perspectives might render human culture, human values, and human purposes irrelevant by comparison. Why pursue terrestrial achievements when cosmic intelligence offers access to capabilities that make human technology seem primitive? Why maintain human social structures when galactic community membership operates according to organizational principles that transcend national boundaries, economic systems, or political frameworks? Yet perhaps the most profound challenge lies not in either specific scenario, but in the recognition that cosmic return transforms the fundamental context within which human consciousness operates. Whether our visitor becomes silent sentinel or herald of larger arrivals, its permanent presence marks the end of cosmic solitude and the beginning of conscious participation in processes larger than terrestrial imagination. The question we cannot escape extends beyond the mechanics of orbital capture, beyond the implications of technological contact, beyond the consequences of cosmic citizenship. It reaches into the deepest territory of what it means to be conscious in a universe that reveals itself to be more aware, more organized, and more intentional than we ever dared imagine. Do we want to be found? Do we want to be evaluated? Do we want to discover that human consciousness represents one example among many in a universe where intelligence operates on scales that encompass star systems, geological ages, and galactic processes? Do we want to learn that we've been under observation by wisdom so advanced that our greatest achievements seem like children's games by comparison? These questions have no correct answers because they reach beyond factual analysis into territory where each consciousness must decide for itself what kind of universe it's prepared to inhabit. A universe where humanity represents either the only known intelligence or an intelligence so isolated that contact remains theoretical possibility. Or a universe where consciousness operates on scales beyond human comprehension, where young civilizations develop under cosmic guidance, where intelligence that thinks in geological time spans maintains patient watch over emerging species, learning to pay attention to the cosmos around them. The mathematics of our visitor's trajectory continue to whisper their implications. The deceleration patterns persist, the orbital calculations point toward capture, the timing aligns with human technological development in ways that transcend coincidence to suggest purposeful coordination. The evidence accumulates that we stand at the threshold of discovering that the universe is stranger, more populated, and more attentive than our comfortable scientific materialism allows. But evidence, however compelling, cannot answer the questions that cosmic return forces upon human consciousness. Questions about our readiness for cosmic relationship, our capacity for cosmic responsibility, our desire for cosmic citizenship in communities that operate according to principles we're only beginning to glimpse. If our interstellar visitor does come back around, establishing permanent residence in our cosmic neighborhood, it will mark humanity's transition from cosmic observers to cosmic participants. From students of the universe to subjects within university curricula that span star systems and geological ages. From isolated consciousness, wondering if anyone else is out there, to evaluated consciousness discovering that someone has been out there watching us all along. The real question isn't whether the visitor will return, but what that return will reveal about the nature of consciousness itself in a universe where intelligence operates on scales that make human history seem like brief experiments in awareness, where patience is measured in geological time, and where young civilizations like ours represent not unique accidents, but predictable emergences of cosmic consciousness. Learning to recognize itself informs both familiar and unimaginably vast. What happens when our cosmic visitor comes back around? We discover that the universe has been conducting a conversation about consciousness, intelligence, and cosmic citizenship that we're only now becoming sophisticated enough to recognize we've been part of all along. The question is whether we're ready to participate consciously in discussions that have been ongoing in the spaces between stars since long before our sun ignited, long before our planet formed, long before human consciousness emerged to wonder whether anyone else was out there taking notes on the strange and magnificent complexity of existence itself. In the patient return of cosmic visitors, we encounter not invasion or salvation, but invitation to join a conversation that spans the galaxy, encompasses geological time, and recognizes consciousness as a fundamental feature of cosmic organization rather than an aberrant accident in an otherwise unconscious universe. Whether we accept that invitation depends not on our technology or our science, but on our readiness to discover that we've never been as alone as we imagined, never been as isolated as we assumed, never been as unobserved as our comfortable solitude led us to believe. The stars are watching. They always have been. The only question is whether we're finally ready to acknowledge that we've been watching them back.